Hello everyone and welcome to the channel. I'm Emmanuel, I'm an Airbus pilot, and welcome to the first tutorial for the Airbus A320. In this tutorial we are going to have a look at the general overview of our flight, and we're going to conduct the preliminary cockpit preparation. So, we are going to fly the Lufthansa Airbus A320-200 from Munich to London in this tutorial series, which is a quick 1 hour and 20-minute flight, which should give us sufficient time to explain everything while keeping busy on the airplane system without any boredom coming up in cruise flight. So do follow me inside now, as we are going to start our tutorial. A quick word over here, I am using the Phoenix A320 for this one, but you should be able to fly this using pretty much any A320 simulation there is out there, given the limitations of the respective A320 simulation in place. Most of the stuff in this tutorial is going to work with the fly-by-wire A320 and with the upcoming INI-built A320neo as well. So let's take a seat now on the captain's seat of our A320. Now, starting the preliminary cockpit preparation, basic word over here. Now, I'm starting this one off a cold and dark panel state, but you can do this from literally any panel state there is. Whenever a new crew boards the airplane, regardless of the state, if engineers have prepared it, if the previous flight crew just handed it over to you, you are going to run these checks. Alright, so we are going to get started right here. And we start by making sure that the airplane is safe and secure for our upcoming operation. So we make sure that the engine master levers are in the off position, the engine mode selector is in the middle, norm position. Then we move over to the weather radar panel and we make sure that the weather radar switches off and the predictive wind shear switches off. Likewise, we make sure that the gain knob is in the calibrated position and the multi-scan and GCS buttons are in auto. Now, if your Airbus is fitted with a slightly different weather radar panel, you basically make sure that the entire weather radar system is turned off, and any of the systems that could influence the displays, like for example the gain, are set into a neutral or calibrated position. So, when the weather radar is checked, we move on to the landing gear lever, which is in the down position, and then we move up to the cockpit and check that the wiper selectors are in off. The wipers need to be off because when the airplane is now being powered up in the next step and the windows are not wet and the wipers turn on, scratching of the windshield surfaces can easily occur. So, with this, we've now made sure that our aircraft is secure for operations. So next up, we're going to power it up. Over here, we got a few checks to run, depending on how long the airplane has been electrically supplied or not supplied. So if you received a cold and dark aircraft, and the aircraft has not been electrically supplied for 6 hours or more, perform the following check. We check the battery voltage, make sure that it is above 25.5 volts, and this indicates that the batteries are charged at least 50%. Now, if the battery voltage is below 25.5, then we need to charge the batteries using an external power unit. So in that case, you would turn them on and then turn on the external power and wait for at least 20 minutes with the battery switches turned off again after the external power was connected. And then after 20 minutes, check the voltage is above 25.5. If it is, great, then you can turn the batteries back on again. If it's not, time for maintenance. So, in our case, the airplane has not been powered for 6 hours or more, so we are going to make sure we've got more than 25.5 volts, and then we can turn on the batteries. Be aware that this needs to be checked with the batteries off. So, batteries are now on, and in case the aircraft has been electrically supplied during the last 6 hours or more, you just turn the batteries on, respectively auto, regardless of the voltage indication that you receive. Now, if the external power avail light is illuminated, we are going to use it, so we are going to turn on the external power. Now, when the Airbus gets AC power for the first time, it is going to run several checks. Like you could just see the fire switches illuminate for a few moments over here. You can see the displays running self-tests at the moment. Looking at the MCDU, we got the FM warnings. We don't have an FMS indication up here at all. So you can see the Airbus does take a little bit of time to boot up. And just like any computer, you shouldn't interrupt it in this sequence. So we are now going to just sit here, wait for the plane to boot up. And a good indication that it has finished its startup process is that you're going to hear the triple click. Like this. So this is now our indication that the airplane has booted up and that we are safe to continue with our procedures. So the next thing we're going to do is the Apu Fire Test and Apu Start. Now obviously you need to decide whether you really want to run the APU yet, or if you want to delay the APU start to preserve a little bit of fuel or due to noise constraints. A good indicator for that is always a look at the cabin temperatures that you can find on the condition page. So you can see in the cockpit it's rather warm, in the cabin it's okay. So let's just fire up the APU and get the air conditioning going over here in order to get nice conditions throughout the entire airplane. Be aware that another role might be the condition of the skies. Like, we've got a rather overcast sky today, so the plane is not going to heat up as quickly, but always remember you've got a huge aluminium surface over here, and if the sun is shining on that, then even at temperatures that are just below 20 degrees centigrade, it might get hot in the cabin really quickly. So you need to make a more or less new decision every time whether you want to run the APU straight away or not. Okay, today we are going to decide to run the APU. So before we start it up, the first thing we're going to do is to set our radios up, because we want to be reachable by air traffic control. So VHF 1, you use the active frequency. VHF 2, you are going to turn on guard frequency, and then also make sure that you listen to both of them so the switches are pulled out. Like this, you don't listen. Like this, you do listen. And then also make sure that they are set to a decent volume, like in here, the middle position. So to the left gets quieter, to the right gets louder. So something in the middle position. And since you don't want to wear the headset for the entire time, you also want to turn the loudspeaker to a decent volume. Like something in the middle usually works rather fine. On the ground you can even use a little bit less, like this. Okay, so now, next up, since the radios are now set, we are going to go ahead and run the APU Fire Test. So APU Fire switch located on the top middle of the overhead panel. We press the test button down here, and this is going to illuminate the discharge and squib lights, the APU fire light, and we also get the continuous repetitive chime and the APU fire warning down here on the ECAM. Okay, so this is working. So now let's release the test switch again, and now we know that the APU is safe to operate, so we can start it up. Press the APU master switch down here, and then wait for at least 3 seconds. And after those 3 seconds, you can press the APU starter. Alright, with that our APU start is in progress. We can see that on the ECAM down here, where you will first see that it is going to open the flap at the back of the airplane, which allows for air to flow in, like now. And once that has happened, the APU automatically continues with the startup process. Now, depending on the operator, there might be a certain time limit imposed from the time where the APU becomes available to the time where you can actually turn on the APU bleed. Now, this varies significantly between operators. General Airbus recommendation is to wait 3 minutes between the completion of the APU start and turning on the APU bleed, so that the ducts and everything involved has a little bit of time to heat up before you are going to introduce warm air into the entire system. So now that we have a completed APU start, I am going to start the timer over here. We'll give it 3 minutes, and then we're going to turn on the APU bleed. In the meantime, however, we can continue with our procedures. So next up, we are going to start the IRS alignment process. And this is done rather early in the sequence because the IRS, depending on where you are, might need up to 15 minutes to align. So moving on to the overhead panel then, you can see that we've got ADR1, ADR2 on the right hand side and ADR3 in the middle. The reason for this arrangement is that ADR1 supplies the captain's instrument, so it is located on the captain's side. ADR2 supplies the first officer's instrument, so it is located on the FO side. And ADR3 supplies the standbys, so that is the reason for the arrangement of the panel. You always operate it in a sequence 1, 2, 3. So always operate it in that sequence so that you get the correct motion into your head and that you can never accidentally turn off the incorrect unit, as that is an irreversible action. So, let's quickly talk about when a full IRS alignment is needed. So a full IRS alignment is needed before the first flight of the day, or when there is a crew change, or when the departure airport is located between latitudes 2 degrees north and 2 degrees south, or when the GPS is not available and the nav8 coverage is poor on the expected route, or when the GPS is not available and the expected flight time is more than 3 hours. A fast IRS alignment must be performed if a complete IRS alignment is not necessary and the difference between the IRS positions and the FMGC position is at or above 5 nautical miles, which you can see on the MCDU position monitor page, which we are going to talk about later. So to perform an alignment, the aircraft must be stopped on the ground. Any aircraft movement will automatically restart the IRS alignment. Do not align the IRS during engine start or while the engines are running. Okay, so with the prerequisite now understood, let's go ahead and we're going to start number 1, number 2, and number 3. When we turn them on, we'll see the on battery light come on for a bit, and then it is eventually also going to turn off again. Now, depending on the unit that you have installed, up here in the Phoenix we have a rather old unit. You might have a display up here. If you do have it, switch it to system number 1 and switch it to the present position or to the status page, which you can also do, which tells you the time to align. So in this case, 8 minutes over here. Note that you will also get that time shown to you on the eCam over here. So now with the IRS alignment in progress, we continue setting up our airplane. So the next thing we're going to set up is the lights of the cockpit. Now, before we start that, we have just reached 3 minutes over here, so let's go ahead and turn on the APU bleed, so that our cabin is going to be nice and cool by the time that our passengers show up. Okay, so now let's go ahead with our setup, and what we are going to do over here is that we basically tune the internal lights of the airplane the way we need them. So since it's daylight today, we can just turn them all off. So you've got the integral lighting of the overhead panel located up here. Then you've got those for the AFCU located down here. The general FCU brightness is located here. Turn it to a setting that is going to work well for the flight. So in dusk and dawn or night, you might want to dim it down a little bit. And then going down to the main panel, we've got our integral lighting once again located over here. Do note that this also binds the audio control panel's lights. So as you can see, they might go all the way off if you select this all the way off. Floodlights are located over here, and these basically are the lights that you've got over here for the panel. Some people like to use them, others don't. Personally, I'm a fan of them, but there are lots of colleagues who just keep them off even at night as well. And finally, you've got the floodlight located down here. This is a floodlight that illuminates the lower part of the pedestal, pretty much like, well, you can see how it's getting a little bit brighter over here. It's quite nice for cruise flight, or you can also turn it on very slightly on approach, so that you've got a little bit of lights down here while not disturbing you when you're looking outside. Okay, now that our lights are set, next up we're going to move on to our EFB, and in here we basically just make sure that the EFBs are started and that we've got the latest software on it. So things like updating the chart database, updating the databases of the performance tools as applicable. Now, when that is done, the next thing we do is to initialize our FMS with a pre-initialization. So this is literally only a pre-initialization. We're going to make it more complete at a later stage in the setup procedure. But what we want to do right now is the following. First of all, you go into the ACAS software, and at this point a little notice that there are different ACASs available on different A320s. So The software that you see installed in this tutorial might not match the software that you have available, but there are a couple of general things you can do. So when you go into the ATSU and then go on to the AOC menu, then you will somewhere find a space to initialize your flight. So in this case, we've got the flight init over here. We press the initialize data request button, and this is now going to uplink the data of our flight into the airplane. Now, this usually comes from SimBrief, but depending on your simulation, things might vary a little bit. So up here you can see we've uplinked our flight with a flight number Lufthansa 7 Victor Victor from Munich to Heathrow, Auckland, Manchester, estimated time en route an hour and 22. Now this might on some Airbus models also start the initialization and uplink of the flight plan itself. Now in no simulation that I'm aware of, this is currently the case. So what we got to do in order to start our FMS Preinitialization is to go to the MCDU menu, then FMGC. That brings us on to the airplane overview page. If for whatever reason you end up somewhere else, like on the init page over here, you can always access this page by going data and then aircraft status. And that is going to bring you back to this page. So on this page, we verify the aircraft and the engine type. So we've got an A320-200 with a CFM56 engine here. And we make sure that the nav database is actually active. Now, the nav databases are an interesting way in this Airbus, or in any Airbus, to also clear any data you have in the MCDU. Never do this in flight, but on the ground, if you switch the databases, so let's say we flick from the active to the secondary, like this, then you are going to delete anything that previously was in the FMS. So any remains of a previous flight plan, etc. are going to be deleted. However, do note that you don't have to do this as part of a normal pre-flight procedure, but it is useful information that is there in case, for whatever reason, you do have some stuff in your MCDU. Okay, so now that we verified that our airplane's performance is correct, in the real world we would also check the idle and performance factors. For flight simulation, that is not so much of a factor. You can go to the init page, and up here, either your flight plan might have uplinked automatically, it might also have uplinked into the secondary flight plan. This does happen on some aircraft, and under certain circumstances, if that happens, you can just activate it over here. But in general, on the init page, you are now going to press the init request button if no automatic uplink has happened yet. This is going to uplink the flight plan from your company into the aircraft, as you can see over here. On top of that, we also enter our flight numbers. So in our case, as we have mentioned previously, it's going to be the Lufthansa 7 Victor Victor and put that into the flight number field. Also, check all the scratch pad messages that you're getting down here. For example, we've got AOC active flight plan uplink. Make sure that the message is appropriate for the phase of flight, and then clear it away. Alright, the last thing that we're going to do at this point is to confirm our IRS alignment. Basically, as long as GPS is available to the aircraft, IRS alignment is fully automatic, so you don't have to do anything with this. But in case GPS is not available, or in case that you do want to do something, you go into the IRS align prompt, and then you can set the respective coordinates over here. Just be aware that by default it shows the coordinates of the aerodrome reference point, as you can see here in the middle. So if we pressed align on reference now, don't do it, but if we did it, then it would align the IRS to the aerodrome reference point, which might not be the same as the actual aircraft's location at the gate, and that might be a source for an error in your IRS alignment. So we are not going to click anything in here, we simply verify. As you can see, all three IRSs are aligning on the GPS position, and that is good. So that is the last thing we got to make sure in here. Alright, so that is our IRS or our FMS pre-initialization complete. From here we can go on to actually accept the airplane for the flight. Remember, the airplane might have technical difficulties that render it unusable for the flight, or it might have any kind of a problem. So in order to recall any problems that the previous flight crew had, we're going to press the recall button for 3 consecutive seconds. So press it, hold it, 21, 22, 23, release it, and now up here you can see it tells us normal. So there were no faults previously stored or cancelled by the previous flight crew. From there we go on to check the logbook and any MEL items that we might have, and check that we can actually fly with it. And we are also going to check the aircraft configuration summary. Now this is especially important in case you're flying a fleet or a mixed fleet in your airline. Now aircraft configuration summary for us, in the Phoenix, we can find that down on the sim settings down here, and we check things like, for example, on the airline modifiable information, do we have things like automatic navigation and go-around installed? No, on this plane we don't, so we'll have to push the heading button in order to navigate on a go-around. We don't have automatic TCAS abilities, we don't have FLS in this airplane, and so on. So this is the kind of stuff that you check over here in order to know what kind of configured airplane you are flying. Last but not least, when this is checked, we also check for any OEBs. Now, OEBs are bulletins from Airbus, which are going to tell you about any temporary abnormal behavior of the aircraft. That might be things like a certain software bug and stuff like that. So when checking OEBs, it's always a good idea, if you haven't flown the plane in a while, maybe check the social media channel of the airplane's developer to see if there are any known bugs and known workarounds for that. So finally, when all of that is done, then we can accept the airplane for flight. So now that we have decided that the airplane that we're sitting in is actually airworthy, and we are going to take this one for the flight in question, we're going to do our preliminary performance calculation. And that one you do in the electronic flight bag on your departure performance calculator. Now, a few basic things. In the Phoenix, I am first of all going to download my flight data from SimBrief over here so that I have a flight plan available. Now, after that, let's have a quick look down here and decide on how much fuel we actually want to take. So, if we have a look into the weather data for our destination, we can see a little bit of gusts forecast, but nothing too severe. Overall weather is good at our destination, London Heathrow. And if we have a look into our alternate Manchester, then you can see down here there is a Prop 30 temporarily heavy rain, but overall not too bad. So overall I would say it's Heathrow that we're flying to, so chances are we might have to fly a holding or two. So let's take some 15 minutes extra fuel to cover for that. Apart from that, no reason to take extra. So going on to the operational flight plan, if we have a look into the fuel section down here, we're planned with 6,100 to go airborne, 173 taxi, so we're looking at 6.3 for our 6.3 for our minimum fuel. And then if we say that we want to take about 15 minutes extra, you can make a nice calculation here. Minimum contingency shows you how much you need for 5 minutes of fuel, so that's about 200 kilos. In other words, if we want to depart with our 15 minutes extra fuel, we're going to take 600 kilos on top. Generally on the A320, that goes for the Neo as well by the way, 200 kilos equals 5 minutes of flying time. Alright, so we said 6.3 plus 600 kilos, so we're looking at 6,900 kilograms of fuel. We're going to start the process of loading that on today, because that is going to tell us our preliminary weight over here. So, start loading your aircraft up. In our case, 6,900 kilos is what we're going to take, and we're going to apply and load that. Loading by GSX in this case, but use whatever you have available on your aircraft. Now, as I said, we take 600 kilos additional fuel, and that means that we're now looking at a takeoff weight that is going to be 600 kilos higher than this. So we've got 64 tons over here, plus 600, and then we just want to be on the safe side here on the preliminary performance calculation. So if we take 65 tons of takeoff weight for our calculations, we're going to be safe. Now, let's head over to our takeoff performance calculator and start doing our performance calculation. The reason we do it at this point in the procedure already is because we need to know if we are limited on our takeoff performance, so that we could decide on, for example, less fuel in order to make a fuel stop later on, or maybe leave some passengers or cargo behind if required. So in general, we do have a little bit of data pre-filled here. So Munich 26 right on a dry runway. For the flap configs, we're going to take optimum. We are not going to force toga. We want to maximize use of flex temperature. Anti-ice as needed. In our case today, it will not be needed. Packs as needed. We're going to keep them off over here. I have done a more detailed video on the takeoff performance, which I'm going to link in the video description below. So if you are looking for more information, just have a look at that. Now, takeoff weight, we said we're going to use 65 tons of takeoff weight over here. And if you're wondering why I'm not synchronizing the preliminary load sheet that we might have gotten, that is because I don't want to calculate it down to the very last kilo, but we want to be a little bit conservative here in case we get some last minute passengers or cargo on board. So I just want to calculate a little bit more. We can also leave the CG for our takeoff empty at this point, and of course we're going to insert our live weather into the calculator. Now the last thing we're going to do here is to select an appropriate intersection for our departure. So in our case, for example, on runway 26 right, we might be looking for something like intersection Alpha 12, so that we can make some conservative calculation. Now, hit calculate as needed if it didn't do it automatically. And now the only information that we really care about that we get here is our takeoff performance limited weight. As you can see, we're limited to 83,722 kilos, and that is far more than we expect, so we are good to go. Alright, so when our preliminary performance is done, then we just got one more step to do before we are going to finish up the preliminary pre-flight preparation. So this is now checking basic system status to make sure the airplane is safe for our walk-around. So first of all, on the door and oxygen page, we make sure that we have sufficient oxygen pressure available for the flight. Now, you can see over here, 1,800 is more than sufficient, basically, and that is a very, very basic way to do this. When the oxygen pressure falls to 1,000 psi or below, or in case you've got such a system installed in the aircraft, it is optional equipment. If you've got a half box or something like this around the PSI, then you need to check the minimum flight crew oxygen chart in the flight crew operations manual. So that's the oxygen checked. Next up, we're going to move to the hydraulic page, and over here we check the hydraulic quantities are sufficient for the flight. Now, the quantity indicator works in a way that up here you've got those little boxes, and that box basically tells you the maximum and minimum amount of acceptable hydraulic quantity in the reservoir. The location of the box might move around during the flight, together with the indication of how much there actually is inside throughout the flight, as hydraulic quantities might be used, for example, to uphold the landing gear. So the boxes might be moving around, but what we want to make sure is that the arrow on the left side is always located within the box on the right hand side. And that way we can verify that we've got sufficient hydraulic quantity available. Next up, we're going to move to the engine page and we check for the oil quantity. Now, depending on the Airbus model that you are flying, the numbers you see here might be X'd out. If you only find X's like on the top, over here on the bottom, then you can manually energize the FADEC in order to view the values available. You do this on the aft overhead panel, and if you just move over there, then you can find those switches right up here. Engine, FADEC, ground power. Those are guarded switches because you're not supposed to touch them when the airplane is being operated, except for this very case right now. So if you don't see any numbers on the engine ECAM screen, lift the guard, turn the FADEC ground power on, and you can see this now fully energizes the FADEC, and now you have to have those numbers available down here. Alright, so like that you can check for the engine oil quantity, and you basically got to make sure it is above the minimum. So determining the minimum, well, if it turns amber, obviously you got a problem. If it's not amber, then calculate about 0.5 quarts per flight hour, and you will have a very conservative calculation done. in order to verify that your oil quantity is sufficient for the flight. Now, when that check is completed, in case you had to turn on the fader ground power, be sure to turn it off again and put the guards back down, and that is going to de-energize the fader X. Now, with that, our quantities for operating fluids are checked, so we can deselect the ECAM page. If you deselect it, it's always going to revert to the default page for the phase of flight. So on the ground, for example, that is the door oxygen page when the engines are shut down. Next up, we check that the flap indication agrees with the flap lever indication. So we're looking at the flaps completely retracted over here, and we make sure that the same is set on the flap lever. If the flaps were at an extended position, then you would also match the flap lever to that position so that the flaps are not going to move when you power up the hydraulic systems. Next up, we move down to the speed brake lever and we make sure that it is in the retracted position and disarmed. How can you check that it is disarmed? Well, if you pull it up, you're going to see that little white part on the lever, so make sure that it is in the disarmed position. From there, we move on to the parking brake, and the parking brake we don't check through the switch, but through the systems. So when the parking brake is set, you always have to have pressure on the hydraulic triple indicator. So the brake pressure indicator over here, as you can see, shows that we do have brake pressure applied, and we also have accumulator pressure up here. Also, we get the parking brake message up here on the ECAM. Now, if you had rather little accumulator pressure, you could always recharge the pressure by turning on the electric hydraulic pump. Now, I am going to demonstrate this to you, so we need to run a check here anyway, and that is the check of the brake pedals. So what we're going to do is we turn the parking brake off with the chocks in position. Now you can see that the brake pressure has run down to 0. Next up, we're going to press our brake pedals, and we make sure that the brake pressure does actually rise. When that is done, you can just keep the pedals pressed and set your parking brake again, and like that you can conserve a little bit of accumulator pressure. Now, in case the accumulator pressure is at a rather low position, I'm just going to demonstrate this to you. So, just pressing the pedals a few times, you can see how the accumulator pressure decreases every time here. So if you've got a rather low accumulator pressure, like we have right now, then you can always recharge it by powering up the hydraulic systems through the electric hydraulic pump. Before you do that, always make contact with the ground. So let's talk to the gentleman on the ground here. Ground from cockpit. Go ahead. Can we pressurize the hydraulics? Yes, you can pressurize. Okay, so now that we have gotten clearance to pressurize the hydraulics, we're going to press the electric hydraulic pump, and you will be able to see once the system is powered up that the accumulator recharges rather quickly. And that's it already. With that, the brake pressure is recharged, and now we can turn the electric hydraulic pump off again. Don't run the electric hydraulic pump for extensive periods of time, as that might at some point start damaging the electric hydraulic pump. So, before you head out for the walk around, make sure that the parking brake is set so that the brake wear indicator pins can be checked on the ground. So, with that, the last thing we do is to check for circuit breakers and anything that might be pulled. So, the easiest way to check circuit breakers is to go up and nearby like this, so that you can see if something is popped. Let's just pull someone out here. You can easily see how that is popped and how you've got that little white indication over there at the bottom of the breaker. So if anything is popped, liaise with maintenance to make sure if anything has a problem. Okay, so in this case, I'm just going to reset the breaker. Never do that without contacting maintenance if you find something popped. Okay, so, and that completes the preliminary pre-flight procedures. So, from here on, the airplane is safe for operation, and we can start our pre-flight procedures. But that is going to be for a separate video. With this, I would like to thank you very much for watching. Hope that you learned something, and with that, I would like to say thank you very much for watching. See you all again on the next one. If you're up for more, don't forget to subscribe to the channel, leave a like and comment to let me know your opinion. Thank you very much for watching, and then I see you all again on the next one.